Hello,
And welcome to Crafting the Future,
exploring bioprinting.
and additive fabrication in the world of craft making. I am Petra Garajova and this is Eduardo.
In this masterclass, part of the distributed design platform thanks to the World War Craft in Europe, we will dive you through some amazing masterclass on 3D printing, biomaterials, and digital fabrication for craft making. 3D printing is an additive manufacture process that works at adding material layer by layer. This process, commonly known as 3D printing or also known as additive manufacture, AEM, is a process that focuses on creating a three-dimensional object. This technology has been with us for a long time, actually since the 1980s, but was not widely available because there were a lot of patents that hold the constraint of this technology without actually paying royalties. 3D printing, also known as additive manufacturing, is a process of creating a three-dimensional object adding material. This process usually adds layers of material after layer. This process was invented actually in the 1980s, but was not widely available because its use was constrained by some patents. These patents were used by the two main big companies nowadays in the world, Stratasys and 3D Systems. This patent expired in 2005, and that led to the development of this and expansion of these technologies, as a professor from the Bath University started developing this technology with the help of other open source collaborators. There are many additive manufacturing techniques. All of them, they have really complex acronyms, but the most widely used are FDM, FFF, SLA, Loom, and SLS. FDM, that is one of the most expanded ones, is called as fused deposition modeling. Even if 3D printing was invented in the 1980s, the late adoption of it is normal in the industry, as usually 20-25 years is what it takes to any production methodology invented to actually start and expand to be used into mass production. Nowadays, this is still not a mass production process, but a lot of industries like the aerospatial, car, textile, and shoemaking are taken into account, and it's a process that is really configurable and will help you to create much more innovative products with taking less materials in faster processes. One of the main benefits of 3D printing is the capacity to use one-to-one production. What does that mean? We can create one single part production processes completely customized without actually incrementing the total cost of the object. That means completely customizable parts at no cost. This process is quite fast compared to other manufacturing processes. That doesn't imply big changes in production chains. But from big production industry, we can also go to small scale manufacturers. That means each craft person, designer, or creative can start producing his own, as this technology is quite affordable nowadays for small production batches. 3D printing is a manufacturing process that allows the creation of free-form three-dimensional objects. What does that mean? We can create high complexity objects without almost not constraint. This is relative because it depends highly on the 3D technology being used. This technology has been widely implemented to create really high complexity parts, from rocket engines to car engines to prosthetics for surgery, dental implants, and it's a technology that has been expanded among a variety of fields. The development of 3D printing is growing up to 300 times a year, and the patents around this field are exploding as the new technologies and new possibilities with this are coming up. 3D printing is actually a digital fabrication process. What does that mean? We are using a machine like the one that we have on my back, that are mechanical machines with motors and some microcontrollers to actually produce objects. These machines are controlled by the computer. There are different types of digital fabrication processes. We can find subtractive methodologies as CNC fabrication or laser cutting. 3D printing is one of these three big fields of digital fabrication. Even if there are a lot of and wide techniques available in the market, there are few of them that they are not really constrained, as the acquisition of this is quite low. There are powder material 3D printers, there are resin material 3D printers, there are fused deposition plastic 3D printers, and also tissue for 3D printers. What does that mean? That not now, right now, but in the future, we are able to print organs, as we will be able to replace, for example, human hearts, that right now could not be replaced without actually another human. This allows for what is known biomaterial 3D printing, that Petra will talk to you about in a few moments later. So what materials can we print after these 25 years of development? Actually, we are way more ahead than 25 years. But in the last 25 openness of the technology years, we are able to print from almost any kind of materials, from aluminum, steel, carbon fiber in a continuous fiber fabrication processes, all kind of thermoplastics, some kind of resins, and also stones, wood. Don't be amazed too much by all the possibilities of materials, as some kind of materials are quite complex to use. But that doesn't mean that this technology is not available. You need to remember how the first microwaves were in the market. They were completely expensive and nobody could access. Nowadays, everybody has a microwave on their home. So imagine technology as something that evolves and gets cheaper at a lower price point, allowing for more accessibility. Right now, we are at the point that 3D printing is accessible for a lot of designers and creatives, as has reached a price point that is easy and accessible. 3D printing works in a sum, adding layers of materials after layers. You need to imagine as you are building a Gothic church. You are putting mastering blocks one after each other. In here, we are doing this at a really small scale. We usually talk about the scale of 0.5 to 1 to 3 millimeters. That's really small. We are talking on the 0.1 millimeter scale. That means micron scale. We can produce high accuracy objects with really good surface finish. This surface finish is still not perfect, and this process in heavy industries where they need heavy tolerances, for example, jewelry, this process is combined with molding and casting or subtractive techniques, CNC, to get a perfect surface finish. One of the downsides of 3D printing is also that the objects are not homogeneous in the mechanical behavior. As we are adding layer of material after layer, usually the objects are stronger in the X and Y axis and weaker in the Z axis. This is changing nowadays with new techniques, as for example, metal is made by sticking with a laser powder metal. That means we are basically fusing powder metal together. This, after is put in some ceramic kilns, that is called sintering process, that helps harden and get a full homogeneity metal model. This allows now, for example, the latest rocket of, probably you know, of Tesla company, that is SpaceX, to actually produce the full rocket engines that are actually going to the space with these kind of technologies. 3D printing is considered a weightless process. That means that only uses the total amount of material of the object you want to produce. That's not completely true. Sometimes when you are producing a high complexity object, you want to use certain print that you are using to actually hold another part that you want for your final object. That is called a support. Why? The same as when you are building a house, you need some scaffolds. The same we need in 3D printing. This depends completely on which technology you are using. This happens usually, for example, for SLA, FDM, or FFF types of technology. Some technologies have the powder bed, they don't need it, as the bed full of powder is already working as support. How we produce a three-dimensional object into reality? First, and always, we need to start with a three-dimensional design. That means you make a three-dimensional model. You cannot just input two-dimensional plans. You need to create a full three-dimensional object on the digital wall. You want to actually create the one exactly that you want to create. And why I say exactly? Because of the high accuracy of 3D printing. This technology, we are always talking about microns in the worst case scenario, sometimes even lower. FDM technology, that is one of the most expanded ones, thanks to the low acquisition point prices of this one. FDM technology is one of the most expanded ones. Why? because of the cheap price point of this technology. This technology has some manufacturing constraints. It has low surface finish or low quality on the surface. What does that mean? We can see at some point the little layers that conforms our object. Why? The layer height of this technology is usually between 0.1 to 0.3 millimeter at layer height. That means we can distinguish a little bit these lines. This is fastly changing, and we see nowadays quite accessible machines that uses the latest technology as LiDAR, vibration dampening, and other sensors to actually improve how we see these layers and to make them disappear and almost invisible. Sometimes when we 3D print, we also need to have a little bit of post-processing. That means that we need to sand, polish, or make a surface finish of the part that we want to work with. Other technologies, as SLA, actually they have almost invisible layer height. Why? Because the layer height that we are using are 0.02 millimeter high. These technologies work by hardening ultraviolet photosensible resins. That means they use light to harden a liquid to produce a hard object. You might have seen for these amazing YouTube, Facebook, or other social media videos where actually a three-dimensional object comes from nothing, like from a resin pool. Overall, 3D printing offers a unique range of possibilities and capabilities. First, we can prototype in a couple of hours. Before, to produce the same three-dimensional object, if we could do it, it would take weeks at least to get it made. We can prototype in a couple of hours. We can open up new possibilities, and we can iterate fast to our prototypes, still with almost no cost. These techniques also is highly flexible and allows to change a lot all the designs that we produce, and we can produce completely different designs all the time. For example, the 3D printer you see in my pack, all the parts have been printed by machines like his own. That means that a machine like the one that I have here has been producing its own parts. So we can use machines to produce other machines at this level of complexity we are working on. 3D printing is not only for industry or heavy manufacturers, but also allow a lot of customization for crafts, artisans, creatives, and other innovators. Let's talk about a little bit on how this technology influences the craft field. For example, let's say you are a jewelry designer and you want to create a unique piece using natural materials. With biomaterial 3D printing, you can design a digital model of your piece and print it using biocompatible materials, bioplastic or bioceramic. The result is one-of-a-kind piece that is both environmental friendly and unique. But 3D printing has the potential to be used in a wide range of craft making applications, from fashion to textiles to pottery and sculpture. The possibilities are endless, and technology continues to advance. We can expand to see more and more exciting and innovative applications of bioprinting. I have been talking and changed the topic of bioprinting. Why? Bioprinting is using additive manufacturing with biocompatible materials or natural source materials. As mentioned earlier, in additive manufacturing, we are seeing a huge change in the industry. Traditionally, we have always been printing with thermoplastics and other kind of photosensible resins. Now, with steel, ceramics, we are also changing to biomaterials. These biomaterials have a huge complexity and there's still a lot under development. That means we have a lot of room of exploration from the material point of view and also from the design possibilities point of view. As new materials come up in the market, we still see and look for new design opportunities into them. So I'm not the expert in biomaterials. So now I will ask Petra to kindly talk you about what are biomaterials and how this could be used.
Answering to Edu, if we are talking about design and prototyping, you can imagine that you are, for example, a jewelerist who would like to produce a collection made of biomaterials. So what you can do is to create all the process more sustainable and to customize it what you want to achieve. For example, you can 3D print your own molds where you can cast it, the biomaterial, and you can customize and make it very personal what would you like to achieve. It will allow you to create more complex geometries using even 3D software and 3D prototyping. So within an hour you will be able to produce as much prototypes as you want. You will make them customized and personalized to your purpose, and also it will allow you to create a completely different shape. For 3D bioprinting, we usually use biomaterials that are derived from a biopolymer that is plant or animal based. Plant-based biopolymers can come from sugarcane, starch or potato starch. But all these plant-based biomaterials can be also combined with animal-based materials that are usually proteins. For example, it can be chitosan or gelatin or keratin. For bio 3D printing, we have to create a biocomposite or bioplastic.
As designers, creative and makers, we have the opportunity and the duty to create a more environmental ready world. That means we can change the processes, the innovation and the methodologies on how we think and produce objects. 3D printing seems a wise technology for this, as it reduces the total amount of material waste and doesn't imply the big change of manufacturing production lines, as we can produce customized objects for every client. This creates a huge opportunity for businesses and the development of sociocultural changes. This is widely changing at the same time with this environmental friendly wave that is driving completely through all the aspects of our life, as we want to create a better and a safer place in this world. We can start using waste material, food leftovers and other kinds of biomaterial compost to produce new materials and designs. And we start to need to think how we change, design and implement these new technologies and materials.
The history of bioplastics can be traced into 1990s when the researchers started experimenting with bioplastics. The very first explored bioplastic was based on cellulose. The reason why the usage of bioplastic was more explored was to reduce the dependence on fossil fuels and to reduce the pollution. During this time, researchers developed new methods for creating bioplastics and their applications. However, it wasn't until 1990s that bioplastic began to be widely used in a commercial product. Since then, bioplastic have become more common and the market is growing rapidly. Today, bioplastic is used in a wide range of products, including packaging, automotive parts, textiles and medical devices. It wasn't until 1990s that bioplastic began to be widely used in commercial products. Since then, bioplastic have become more common and the market is growing rapidly. Today, bioplastics are used in a wide range of products, including food packaging, textiles, and medical devices. It's worth mentioning that not all bioplastics are environmentally friendly. Some are made with genetically modified crops, and some of them are not biodegradable. They require high energy to be produced. Therefore, it's important to mention to look into specific properties and production process of bioplastic to evaluate their environmental impact. As we continue to explore the potential of bioprinting and digital fabrication in a world of craft making, it's important also to consider the use of bio-based materials in the maker culture. Bio-based materials are materials derived from living organisms or their metabolic products. They can be used in the same way as traditional materials, but they offer us more sustainable and eco-friendly options. One of the most commonly used bio-based biomaterial in the makers community is bioplastic. Bioplastics are plastic materials that are derived from natural biosources such as biomass, and it can be, for example, cornstarch, potato starch or sugarcane. They can be molded, casted or extruded. They can be extruded in different shapes and forms. They can make excellent choice for use for bioprinting and other digital fabrication processes. There are several different formulas for bioplastic. Each of them is very unique and it has its properties and characteristics. For example, the most common one is polylactic acid, PLA. It's the bioplastic that is commonly used in 3D printing due to its low melting point and good mechanical properties. It can be molded into various shapes and it's also biodegradable. It makes an excellent choice for environmental conscious makers. Other bio-based materials that are commonly used in the maker community include bamboo, fibers, cotton, wool or flax. These materials can be used in a variety of applications, including textiles, furniture, product design and other home goods. In addition to their sustainable benefits, bio-based materials also offer a number of advantages for makers. They are often less expensive and they can be more accessible, easily available than traditional materials. They are also used to create unique and innovative designs that stand out in the market. As we continue exploring bioprinting and digital fabrication in craft making, it's important to consider the potential of bio-based biomaterials as sustainable and innovative option for creating unique and high-quality products. Whether you are a craft maker or designer, maker incorporating any types of biomaterials that can help you to improve your designs and also to shape an eco-friendly future for the world of craft making. I would like to explain a little bit about material science and material practice. Material science is a multidisciplinary field that involves the study of properties and behavior of materials such as ceramics, polymers, metals and other composites. It combines chemistry, physics and other research fields. Material scientists use a wide range of techniques to understand how materials behave under different conditions and design new materials with specific properties. They also study materials interacting with other materials and the environment and how they can be used in different applications. But what is actually a biomaterial? Biomaterial is a material that is used in medical or biological applications. Biomaterials can be synthetic or natural and can be used in a wide range of applications, including implants, tissue engineering, and other diagnostic devices. Other examples of biomaterials include metals, ceramics, polymers, or biologics, such as proteins. The properties of biomaterials must be biocompatible and biostable, meaning that they can be safely used with body. In recent decades, biomaterial research has focused on developing new materials and techniques for tissue engineering, which aims to create replacement tissue and organs using combination of cells and biomaterials. Additionally, new technologies such as 3D printing and nanotechnology have allowed for the creation of complex and customized structures. Overall, the history of biomaterials is marked by a steady progression of new materials and technologies, which have allowed for the development of increasingly effective and sophisticated medical treatments. What is important to discuss about the biomaterial is processing, what includes the creation of the used materials, where does it come from, how we are use it, and where we source them. It also depends if it's a waste material. Another main property of the biomaterials is its structure and the main core of the recipe. Usually it consists of a biopolymer, plasticizer, solvent, and then we can also find there another additives and fillers, which can be also sourced as a food waste. Also, every biomaterial has its own properties, and that's the fact that we have to reconsider during developing our own biomaterials, because they have to go accordingly to the properties of the other materials that we are trying to combine with and to achieve a proper solution. One of the important factors is also to optimize the design part of the process according to the material. Not every material will be designed for a specific geometry or the pattern. A biopolymer is a type of polymer that is produced from natural source, such as plants or animals, or another microorganisms such as bacteria. Biopolymers can be composed of sugars and amino acids. Examples of biopolymers include, for example, cellulose, starch, chitin, chitosan, or keratin. Biopolymers have a wide range of properties and can be used in a variety of applications, what can be, for example, food packaging, biomedical devices, and textiles. Biopolymers are considered as sustainable materials because they are renewable and biodegradable, what makes them a good alternative to synthetic polymers. Bioplastic can be used in design for different reasons, including, for example, sustainability. Bioplastics are made from renewable resources such as cornstarch, sugarcane, or cellulose, which are very quickly grown, and it makes them a more sustainable alternatives to traditional plastics, which are made from fossil fuels. Another one is biodegradability. Many bioplastics are biodegradable, meaning that they can break down and decompose into natural substances, and they can disappear in the environment, reducing the impact of the plastic pollution. Bioplastic production can have a lower carbon footprint than traditional plastic, as they are derived from natural sources and don't release as much greenhouse gases in production and disposal. They are also very similar, or even they have better mechanical properties than traditional plastics, and it's making them sustainable for different applications. At the same time, they are cost-effective to produce. Bioplastic can be cost-effective to produce depending on the raw materials used and scale of production. It will create and open new opportunities for designers and makers to create their own innovation way, as they allow for new forms, colors, and textures of traditional plastics, what they usually can't achieve in normal way. It's important to note that environmental benefits of bioplastic depend on the specific bioplastic and how is it produced, because not every production can be effective. Therefore, it's important to consider the life cycle of the bioplastic, including the sourcing of raw materials and its origin, of course production, use and disposal, in order to value their environmental impact.